Have you ever wished for more hours in a day? Imagine all the things you could accomplish with just a little more time, more moments to spend with loved ones, more opportunities to pursue your passions, or simply more time to relax and unwind. What if I told you that Earth's days are actually getting longer? Yes, you heard that right. Our days are slowly but surely stretching out. It's true. Now, don't worry. Time itself isn't slowing down. The minutes and hours we know remain the same. Instead, our planet's rotation is gradually slowing. This fascinating phenomenon means that each day is getting just a tiny bit longer. But how much longer, you might ask? It's not something we can easily notice. The change is so gradual that it goes unnoticed in our daily lives. After all, the change is incredibly small, measured in milliseconds per century. That's right, just a few milliseconds every 100 years. However, over millions and billions of years, this subtle slowing down adds up to a significant difference. Imagine how different our days would be if we look back millions of years. To understand why this is happening, we need to journey back in time to when Earth was much younger. Back then, days were much shorter. We'll explore the powerful forces that have been shaping our planet's rotation for eons. These forces include the gravitational pull of the moon and the sun, as well as the dynamic interactions within Earth's own core. Fasten your seatbelts as we're about to embark on an exciting cosmic adventure to understand why time seems to be slowing down on Earth. Ernie will take us through the vastness of space and the depths of time itself. Imagine a time when dinosaurs roamed the Earth. Now, picture this. Their days were shorter than ours. Scientists estimate that over 1 billion years ago, an Earth day lasted only about 18 hours. How do we know this? Evidence is hidden in ancient rocks and fossils. They tell a story of a younger, faster spinning Earth. As eons passed, our planet's spin gradually slowed down, making the days longer. But what caused this change? The answer lies in the vastness of space and a familiar celestial body, the moon. The moon, our constant companion in space, exerts a powerful gravitational pull on Earth. This celestial body, orbiting our planet, has a profound influence on various natural phenomena. This force is what causes the tides, the rise and fall of ocean levels. The gravitational pull of the moon draws the water towards it, creating high tides in the areas facing the moon. The moon's gravity tugs on the Earth's oceans, creating bulges of water on opposite sides of the planet. These bulges are what we experience as high tides. As Earth rotates, these bulges don't align perfectly with the moon's pull. The rotation of our planet causes the bulges to shift slightly, leading to a complex interaction between the Earth and the moon. This misalignment creates friction, acting like a brake on Earth's rotation. The friction generated by the movement of the ocean water against the Earth's surface gradually slows down the planet's spin. This phenomenon is known as tidal friction. Tidal friction is a critical factor in the long-term evolution of the Earth-Moon system. Over millions of years, it has been gradually slowing down our planet's spin, making the days longer. This gradual deceleration has a significant impact on the length of our days and nights. Think of it like a spinning top eventually losing its momentum and slowing down. Just as a top slows due to friction, the Earth's rotation is decelerated by the tidal forces exerted by the moon. The moon's pull isn't the only factor affecting Earth's rotation. While the gravitational force of the moon creates tides and influences the movement of our oceans, there are other significant factors at play. Believe it or not, our planet's surface is constantly changing. These changes are not just limited to the visible shifts in landscapes, but also include subtle movements beneath the surface. Melting glaciers and rising sea levels may seem unrelated to Earth's spin, but they actually play a role. As the climate warms, glaciers retreat, and the water from the melted ice flows into the oceans, causing sea levels to rise. As glaciers melt, the water redistributes mass on Earth's surface. This redistribution of mass can have a profound impact on the planet's rotation. This shift in mass affects how Earth spins, much like how adding weight to a spinning top can change its rotation. The added weight causes the top to wobble and alter its speed, similar to how Earth's rotation is influenced. Similarly, the slow rebound of Earth's crust after the last ice age, a process called post-glacial rebound, also influences Earth's rotation. This process involves the Earth's crust slowly rising after being compressed by the weight of ice sheets. These changes, while seemingly small, contribute to the complex dance of forces that determine the length of our days. The interplay of these factors creates a dynamic system that continuously shapes our planet's rotation and the passage of time. Section 5. The Earth breathes. Did you know that Earth's rotation might have played a role in one of the most significant events in our planet's history? It's called the Great Oxidation Event, a time when oxygen first appeared in Earth's atmosphere. Scientists believe that longer days, caused by the slowing rotation, might have allowed early photosynthetic organisms like cyanobacteria to produce more oxygen. These tiny organisms released oxygen as a byproduct of photosynthesis, gradually filling the atmosphere with the air we breathe today. Section 6. Deep inside our planet, deep beneath Earth's surface, a molten core churns and flows. This dynamic interior also plays a role in the planet's rotation. The Earth's core is not a perfectly uniform sphere. Its movements, along with the mantle that surrounds it, can create subtle shifts in mass distribution. These shifts in turn can influence Earth's rotation, causing slight variations in the length of a day. Section 7. Measuring time's subtle shifts. We can't feel the Earth slowing down, but we can measure it. Scientists use incredibly precise atomic clocks to track even the tiniest changes in Earth's rotation. These clocks are so accurate that they lose less than a second every 100 million years. Atomic clocks tell us that a day is currently about 1.7 milliseconds longer than it was a century ago. This confirms that Earth's rotation is indeed slowing down, albeit very slowly. Section 8. A strange speed up. Here's a twist in our story. In 2020, Earth did something unexpected. It sped up. This went against the long-term trend of slowing down. Scientists believe this anomaly was likely caused by complex interactions between the Earth's core, oceans, and atmosphere. This unexpected speed up even sparked discussions about introducing a negative leap second. Leap seconds are occasionally added to our clocks to keep them synchronized with Earth's rotation. A negative leap second would be a first. Section 9. The future of Earth's days. As Earth's rotation continues to slow, the days will continue to get longer. But don't worry, this change is happening incredibly slowly. It will take millions of years for the change to be truly noticeable. The long-term implications of this slowing are still being studied. Scientists are working to understand how longer days might affect our planet's climate, tides, and even the evolution of life. One thing is certain: Earth is a dynamic and ever-changing planet. Even the length of our days is a testament to the powerful cosmic forces that have shaped our world for billions of years.